Yeah, just a couple of applications of systems that we can utilize systems to solve. Yeah, this is one. You've got two sets of information here. I've got 5 regular tickets and 6 student tickets costing $112 total, and 4 regular and 4 student tickets costing $83. Yeah, this is a pretty good example of where we might use a system, because the question is, so what's the price of each kind of ticket? Well, I've got 2 kinds, so I've got a regular and a student. You can, make variables however you want. I'm just going to call X equal the price of our regular ticket, and then Y the price of a student ticket. And I've got two equations here, don't I? Because this one says I've got 5 regular tickets, 6 student tickets, 112. So isn't that 5x plus 6y equals 112? To get the total price, yeah, you'd have to multiply the number of tickets times the price of each, and then add those together. And then the second one, very similar. 4 regular, 4 student, 83 would be 4x plus 4y equals 83. Make sense? Yeah, it's just a system. Looks like elimination. I'm going to eliminate the y's. Now we could go with 24, but 12 would be even better. So let's multiply the top one here by 2. So that'll make it 10x plus 12y equals 224. And then the bottom, I'd need to be negative 12y, so I'd need to multiply it by negative 3 on the bottom. With me there? Mm-hmm. So it'd be negative 12x minus 12y equals negative 249. Mm-hmm. Yeah. So now y's eliminate. When I add the equations up then, 10x minus 12x is negative 2x. Y's eliminate. 224 minus 249 is negative 25. So it looks like my x is 12.5. And that's the price of the ticket, so it's $12.50 for x. Then all I need is a y, so plug in x to be 1250. I'm going to plug in x is 1250 right there, so it's 4 times 1250 plus 4y equals 83. Solve that out for y. 50 plus 4y equals 83. Is that right? Yes. Thank you. And then subtract 50 and divide by 4. We got our y. Since it's a price of a ticket, I'll round that off or change that to a decimal. Not quite 9, so it's $8.75.
25 cents.
25 cents.
Mm-hmm.
Oh, yep. So the students are $8.25, regular is $12.50. All right, any lots of concerns there. All right, number 2, we've got $60,000 invested in 2 accounts. Abbreviate that here. One account pays 8% interest, and the other has 6.5% simple. Now, we're talking simple interest. We just got finished talking about compound interest. This is just simple interest. So the formula is a little simpler, put it one way. Go to that. So if the total of total annual interest is $4,500. how much should be invested at each rate. Okay, so we've got two accounts, two amounts. X is, let's say X is the amount at 8%, Y is the amount at 6.5%. Well, the reason this is included here in these systems is because there are two equations really involved here, because what I know, the two amounts, they total to be 60,000, right? I've got the X plus Y must be 60,000. And then there's another equation involved here, the interest equation, let's call it. Since we're talking about simple interest is just principal times rate times time, which is, like I said, a lot simpler equation than what we previously saw last chapter one or two chapters ago, one chapter ago, wherever it was. But and the other thing is we're talking about annual interest, and so the time is 1 year, so it's just interest is principal times rate is all we're talking about. So all I have to do to get the interest on each of these accounts is multiply the principal, the amount, times the rate. Now, what I know is that the total interest is $4,500, and so that just means the interest from account 1 plus the interest on account 2 is $4,500. Well, the interest on account 1 is just the principal times the rate, 0.08 times X, and the interest on account 2 is 0.065 times Y, and so that's our interest equation right there. Yeah, you're just multiplying the principal times the rate in each case there and adding those two together. But it is, you can think of it as a system, and I think it makes pretty good sense. Well, however you want to solve that system, substitution would work pretty well. You could solve, right? Or elimination. I'm going to go with elimination, because all I have to do, like to eliminate the x's, is multiply this top one by negative 0.08. But if you want to do substitution, that's fine too. So it'd be negative 0.08x minus 0.08y equals the negative 4,800. 0.08 times negative 0.08 times 60,000. Is that negative 4,800? And then just copy the second equation there, just treating that as a system.
Yes, it is negative 48.
Negative 48, thank you. Yeah, so that eliminates there. It's a negative 0.015y, I believe. It's negative 300. Which works out nicely. Y is that just 20,000?
The top one's 300, right?
300, yeah, thank you. That's top's negative 300, yeah. Divide by negative 0.015, I believe that's 20,000, right? Is that right? When you divide negative 300 by negative 0.0.
20,000.
20,000. So that's the at 6.5, and that would then leave. So x plus y is 60,000, so that would be x is 40,000, right? At 8%. Okay, is that right? Question or concern there? All right, the other two have to do with break-even analysis here. Sorry about those real quick. All right, the cost of producing X units is C equals 500X plus 10,750. And the revenue is 950X for selling X units. So cost of producing X units is that, 500 times X plus 10,750. The revenue for selling X units is 950X. Find the sales necessary to break even on this product. Well, that's what I was saying. This is a little business problem. Break even analysis. You break even when the cost equals your revenue. And so it's kind of a substitution sort of equation, solving of a system. I want the cost equals the revenue, so to get the cost, C equals R, I would just set these two expressions equal, right? So I just 500X plus 10,750 equals 950X. So it's like a substitution type problem. Just solving that equation. Yeah, break even is when the cost equals the revenue, so you just set the two equations equal. And let's see, subtract 500X would be the easiest way to go here. That's 450X, so that's divided by 450. Looks like X is about 23.88. So it looks like we would need to produce and sell. 23 doesn't look like enough, so I would say 24 units. Make and sell 24 units to break even. That's what that means. That's when the cost would equal the revenue. Now, number 4 just has one, same idea on number 4. Company invests 70,000, kind of a one-time cost. Each unit costs $85 to make. And each unit sells for $120. How many units must be sold to break even? Well, what I'd like for you to do on this is kind of do the same thing. Give a cost function. What would be the cost function and what would be the revenue? I'll probably ask you to give me both of those on this type of problem. And then it's fairly simple to figure out where these break even. Well, the cost is, each unit's 85 to make, but there's a one-time investment up front there for 70,000. So the cost equation, well, I have $85 times each unit, so that's we'll call X the number of units. But then I have that 70,000, so I got to add 70,000 on top of that. It's, like I said, it's just one time, but is that okay? 85X plus 70,000 would be the cost. And then the revenue, you get $120 for each unit, so that'd be 120X would be the revenue equation on that. And so again, we want the break even. Well, break even is when cost equals revenue. So set those two equal. And that would just about do it. Subtract the 85X. Is that 35? 35X. Oh, Make this one really nice. 35x equals 70,000 divided by 35.
2,000.
2,000. Doesn't need to be 2,000, oops, dollars. 2,000 units to break even. Yeah, so. Any questions or concerns? Now,